Good evening. My name is Brandon, and I will be discussing and performing spherification. So, before we get started, we're going to be needing three things. A liquid of choice. So, for this experiment, we're going to be using blue Gatorade and Coca-Cola, and sodium alginate and calcium lactate. Sodium alginate is a naturally occurring gelling agent isolated from seaweed. You can see its monomer right here. I'll move my face out of the way. I don't know if that's in the way, but you can see the monomer right here, as well as what it looks like when it's bonded to another sodium alginate molecule, as well as calcium lactate. Calcium lactate is only being used for the calcium 2+ ion. So something like calcium chloride could be used in place of it. But for this experiment, I do use calcium lactate. To get started with spherification, the chosen liquid is going to be mixed with sodium alginate to make a 1% sodium alginate solution. That is essentially 1 gram per 100 milliliters of liquid. And it has to be heated a little bit to like a light simmer to get the sodium alginate to completely dissolve into most liquids. The solution is then filtered off to get any excess gel that could form, and then left to cool in a refrigerator for 1 hour. That's to get any air bubbles out of the solution, such as in the Coke, which is going to be carbonated, just to help form a more perfect sphere. Calcium lactate is added to a bath of distilled water at 5 grams per liter to make another 1% solution, and that's going to be what we drop our sodium alginate solution. So after the sodium alginate solution is chilled for an hour, it's added dropwise into the calcium lactate, and just like that, the sphere forms around the liquid as it's dropped in. Super cool. So let's just jump into it. I'm going to be doing the spherification of blue Gatorade and Coke. I already measured out 100 mils of both, and I've got them in some pots back here. And now I'm going to weigh out 1 gram of sodium alginate to add into the mixtures and dissolve it. So we've got our first gram of sodium alginate weighed out. I'm going to add that into the blue Gatorade here before weighing out another gram and adding it into the Coke and then making sure it's completely dissolved into solution. Second gram of sodium alginate, it's going to go into the Coke. There's it sitting in the Gatorade. And now I'm going to stir off camera. Both these are not taking the sodium alginate completely, so I'm going to start raising the temperature. I've already started with the soda. Start raising the temperature to get all of the sodium alginate to dissolve into solution. I don't expect to talk about this later, but it's already becoming an issue. So Gatorade is known for its electrolytes, which means it already has calcium in solution. So as I'm trying to mix in this sodium alginate into the Gatorade, it's actually already forming a gel. So I'm going to actually have to stop the Gatorade prop. I'll keep it going, but I don't believe it's going to work. So to get out any gel that is in, or any excess sodium alginate that's in solution, I'm going to strain both of these into here. And then here we go. Both solutions are strained. Give it a tap. Brilliant. And now these are going to go into the already open refrigerator for an hour. It's 10:13 right now. See you at 11:13. The solutions are in the refrigerator. I weighed out about 2.5 grams of calcium lactate, and I'm going to put it into half a liter of our distilled water. And I'm going to get this all to dissolve. This is going to be the bath that we make the spherification, the spheres in, where all the magic's actually going to happen. So I'll mix that in. Oh, look at it. That's pretty. It's been a little bit over an hour. I've got our Coke and blue Gatorade solutions, and I've got our solution of calcium lactate mixed in with our distilled water. And then I've just got an additional plate full of water with a little plate that I'm going to put them on. So I grabbed my Thanksgiving cleaned turkey baster. I'm just going to take in a bit of these, and we're going to drip, 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 drip. We're just going to do a bunch of drops. These are kind of hard to get out, but here are 2 Coke, I dropped one. 2 little Coke ball, 1 little Coke ball. Going to rinse it off in some water and lose it again because they are hard to manage. And I don't know how to comfortably, boom. There it is. There's my sphere. There's a bunch more in here that I'm going to try to deal with. So to wrap this all up, you could see right here, I made a whole bunch of little spheres. The clear ones are actually Gatorade, so despite what I said earlier, they did work out. These are all in varying different sizes and not textures, they're just in different sizes. It depended on the drops. I did try making some bigger ones that I've since thrown away, but they didn't work out as well just because the bigger they got, the harder it was to make a full sphere around it, and so it just became a jelly, which was not fun. It kind of ruined the solution. But I want to taste one after struggling to pick it up. Cheers. It's got the same flavor. It's got the weird outer shell. It's not bad. We'll talk about the chemistry in just a second. Now that we made the spheres, we can talk a little bit about what is happening. So here you can see a very simplified reaction scheme for what is happening. Essentially replacing the sodium ion with calcium ions to cross-link some of these chains together. This is very simplified. They don't look like this. They actually look like this here. Here we have 3 calcium ions bonded to 6 alginate molecules to create this long carbon chain right here and here going around essentially like this simplified picture. So we end up with a large circle around our liquid, which would be in here. A little bit better and more proper photo can be seen here. The green stuff inside is our liquid. So that's both our Coke or our Gatorade, doesn't matter. And this is what it looks like surrounded by sodium alginate. So you can see that it is still forming around, but it's a much looser bond than when the sodium ions, which are these blue balls, are replaced by calcium, which becomes a lot tighter, which helps it lets the sphere stay, and it helps the sphere keep a more solid shape. So the theory behind blue Gatorade is, I theorized the blue Gatorade would not form into a sphere because Gatorade is known for their electrolytes. You replenish your electrolytes with Gatorade. It's what they're known for. So I was thinking that since electrolytes are just essentially charged minerals that you have in your body, calcium is a charged mineral in your body. However, blue Gatorade is not a significant form of calcium, which we essentially determined through this experiment. That's because if there was more calcium in the blue Gatorade, when we were mixing the sodium alginate into solution, it would have become a gel. It did become a gel, a little bit did. However, we were still able to spherify the blue Gatorade, which essentially means that there wasn't enough calcium in it to affect the reaction. However, I was a fan that some gel did form to show that there was some calcium in the blue Gatorade before we mixed it through. So, in summary, Coca-Cola and blue Gatorade were successfully made into spheres by using sodium alginate and calcium lactate, as described earlier above. Blue Gatorade is not a significant source of calcium, so that cannot be where you're getting your daily dose of calcium from. And any liquid or syrup, based on this experiment, any liquid or syrup could be used to turn into a sphere. If you wanted to use something like a syrup, just like maple syrup, and turn it into a sphere, you would probably have to add distilled water into it to get the syrup to be a little bit more liquidy, but the process would stay the same, assuming there's no calcium in your syrup. But here are some works cited, some reports. Bleh. Bleh. Here's my works cited. And thank you for watching. Have a good night and have a good rest of your winter break. Happy holidays.